Good afternoon. I'm Talia Ruscioni, the Education Director at the Bateman Horn Center, and I run these sessions with ECHO Manager Sarah Day. Welcome to our final session of this particular series for the Long COVID and Post-Viral Syndrome ECHO. We will be picking back up in the fall and hope to see you all there. Before we get started, I want to take a moment to thank the mentors for their time and dedication to this series. I'd like to thank Dr. Brown for ensuring we had the means and platform to bring together these brilliant minds, and to the speakers who spent countless hours preparing for and delivering content to enrich this program. And finally, a big thank you to you all who have joined this series and are in this journey to learn with us. Today, we have a very special guest and a treasured colleague in the field, Beth Polak. Beth is a research scientist at MIT studying infection-associated chronic illnesses that include long COVID, ME/CFS, chronic Lyme, and their associated conditions. Beth is also highly involved in the field. At the NIH, she is a member of the ME/CFS Research Roadmap Working Group. She's working to create a national plan to advance research on the illness towards clinical trials. Beth is chair of the NIH's ME/CFS Less Studied Pathology subgroup. She co-organized and led a 4-hour NIH research webinar on less studied pathologies in ME/CFS in January. Beth currently works and collaborates on 3 clinical studies on long COVID and infection-associated chronic illnesses. She's a member of the Patient-Led Research Collaborative, a research organization studying long COVID, and she is a former senior researcher at Harvard University. Beth, we're so excited to have you here today. Well, the floor is yours.
Thank you so much for the introduction, Talia, and thank you to Talia, Dr. Cindy Bateman, and the terrific Bateman Horn Center staff and team for inviting me here today and for hosting this incredible series. It's a pleasure to be here. As Talia mentioned, my name is Beth Polak. Hi, I'm a research scientist at MIT. I'm based in the Department of Biological Engineering in the Tull Research Group and an MIT Immunoengineering Lab studying infection-associated chronic illnesses, which is led by Mickey Tull. My role in the lab is that I lead research on the overlaps, comorbidities, and shared pathophysiology and pathobiology among a group of complex chronic illnesses, including many of the topics that we'll be discussing here today. I also spearhead our expansion into ME/CFS and connective tissue disorders and environmental sensitivities. I have nothing to disclose. So I was asked to speak today to kind of cap off this ECHO series, which will start again in the fall, by talking about comorbidities and less studied pathologies among patients with long COVID and ME/CFS and co-occurring illnesses. This is rooted in the idea that we must think about and collaboratively work towards a more comprehensive approach to clinical care and research in this group of illnesses, because the most severe and most complex patients can often slip through the cracks of both research and medicine. There's also a lot that we don't know and are just beginning to mechanistically study regarding some of the most complex patients, and I'll cover a few of those topics today. The order of my talk today will be 1, a discussion of comorbidities, 2, a discussion of onset patterns across illnesses, 3, a discussion of less studied pathologies across illnesses, including environmental sensitivities, connective tissue disorders, spinal disorders, and reproductive health conditions, and then 4, I'll be talking about next steps for the field, and finally, how we in our lab study these topics and incorporated them into our ongoing research. In reviewing my topic today, I realized that this could probably be a 2-hour talk, and Talia asked me to keep it to just 45 minutes to allow for questions. So there are going to be some parts that I'm going to quickly talk through, and then some parts that will go into more detail about. And so I'm very happy to answer questions at the end. I wanted to start with an important topic that is rightly so getting a lot of attention, which is that after 6 months, about half of all long COVID patients meet diagnostic criteria for ME/CFS. The latest CDC Pulse survey results from March 5th to April 1st, 2024, found that 6.9% of all US adults currently have long COVID. So this is a really significant number of people. And these illnesses share many overlapping features and symptoms. So key shared symptoms between long COVID and ME/CFS include extreme fatigue, post-exertional malaise, or PEM or PEM, which is an exacerbation of symptoms after cognitive or physical exertion, cognitive impairment or brain fog, orthostatic intolerance, and more. These illnesses also share important pathologies, as you can see in Sarah and Chris's excellent figure on the right, which includes in autonomic dysfunction, neuroinflammation, endothelial dysfunction, mitochondrial and bioenergetic dysfunction, immune dysfunction, and more. And importantly, both of these illnesses are extremely heterogeneous and impact many different organ systems. Slide. That being said, these illnesses commonly overlap with a group of illnesses. There are many similarities and high rates of comorbidities between this group. So this group includes long COVID, ME/CFS, dysautonomia, chronic Lyme, HEDS or hypermobile Ehlers-Danlos syndrome, HSD or hypermobility spectrum disorder, fibromyalgia, mast cell activation disorders, and the list of comorbidities can even expand beyond this, but I'm going to focus on this group today. So as I mentioned, I lead a area of research in the lab on this constellation of illnesses. Subsets of patients across these illnesses share onset patterns, both infectious and non-infectious triggers, symptoms, pathologies, and more. So illness clusters, as we know, are not unique to this group. They are commonly seen across diseases with shared pathophysiology. So for example, patients with cardiometabolic diseases frequently have multimorbidity, including obesity, type 2 diabetes, hypertension, and non-alcoholic fatty liver disease simultaneously, highlighting shared etiology between each of these independent disease traits. Commonly studied pathologies in these illnesses include, but are not limited to, neurological and autonomic dysfunction, immune, neurocognitive, cardiovascular, mitochondrial, and metabolic dysfunctions, and more. And I'll get into it, but cross-illness research is a really important area for research expansion and research directions because there may be shared phenotypes across these illnesses that could inform how we think about and design future clinical trials and studies. So this slide has an overview of comorbidities. I have been working on a systematic review across the history of the literature, documenting rates of comorbidities across this group of illnesses. For this slide, focuses on ME/CFS, but one could build a similar slide for each of these illnesses. Within ME/CFS, ranges for these comorbidities include 12 to 70% of ME/CFS patients may have POTS. That said, 90 to 95% of adults with ME/CFS have reduced cerebral blood flow on tilt table tests, so therefore may have type of autonomic dysfunction does not include tachycardia or a diagnosis of POTS, but still have dysautonomia and autonomic dysfunction nonetheless. A meta-analysis revealed there's a 47% diagnostic overlap between ME/CFS and fibromyalgia. 7% in a study of ME/CFS patients, 7% had mast cell activation syndrome, though this is thought to be higher, and clinical practitioners might have more to share on this. I'm not going to talk about the difficulties of diagnosing mast cell activation syndrome, but look forward to even more research on prevalence across these illnesses. And small fiber neuropathy is an important shared feature across these illnesses. About a third of ME/CFS patients have small fiber neuropathy. This slide shows a list of some of their overlapping symptoms. In the interest of time, I'm not going to spend too much time on this slide, but one area of research that's really important is to understand if there are shared pathomechanisms leading to some of these shared symptoms. So some of the shared symptoms include fatigue, cognitive dysfunction, chronic widespread pain, sleep issues, orthostatic symptoms, GI-related symptoms, hypersensitivities, including to new foods or environmental exposures, and symptom exacerbation around menses. This next slide is on common triggers and shared onset patterns across illnesses. So among long COVID, chronic Lyme, ME/CFS, and POTS, the most common causes are infectious triggers, and many types of infections can lead to some of these illnesses. It is also very common for patients, especially patients with ME/CFS and POTS, to report multiple triggers over time with gradual onset. So one key research question, as I overview some details about onset patterns, is how can many different types of triggers, including infections, environmental exposures, and injuries, often multiple different types of successive triggers, how can they lead to similarly presenting and overlapping illnesses? Essentially, something we think a lot about in our lab is, are there many roads to Rome? So many different ways to develop this constellation of overlapping conditions and shared symptoms. And how do onset patterns impact disease presentation, duration, phenotypes, and importantly, how we think about studying treatments or essentially getting out of Rome? So viral reactivation and pathogen persistence is a really important area of research for long COVID, but really for most of these illnesses in the group. It's also important to note that infections can be non-symptomatic, and so there may be many patients who may not be able to identify all of their triggers. So just to overview some of the literature, 20 to 50% of POTS patients report a viral infection as a trigger, though POTS patients can have acute or progressive onset. In a large study of POTS patients, 41% of patients reported onset within 3 months of a precipitating trigger. Approximately up to 75% of people with ME/CFS report infectious triggers. This number varies across studies. Viral triggers of ME/CFS include EBV, human herpes viruses, Ebola, West Nile virus, Ross River virus, and enteroviruses, and more. So, for example, a study of 233 patients who contracted SARS found that 27.1% met ME/CFS diagnostic criteria 4 years post-infection. In a study of 231 college students with infectious mono, 10% developed ME/CFS 6 months after acute illness. And among a study of over 900 fibromyalgia patients, 5.6% could identified an infectious trigger, including flu, colds, pneumonia, EBV, Borrelia burgdorferi, and VZV. And infections are not just viral, clearly, but also bacterial. Chronic Lyme disease is caused by Borrelia burgdorferi, with an estimated about 10 to 15% of patients not returning to health even after treatment with antibiotics. Something that's lesser known is that patients also commonly report physical injury as a preceding event prior to illness onset. This includes surgery, pregnancy, childbirth, concussions, and motor vehicle accidents. For example, in a study of 939 fibromyalgia patients, physical trauma or physical injury was the top reported trigger, and it was about 4 times more likely than infectious disease triggers. And just a reminder that not all patients may know all of their triggers, and infections can be non-symptomatic. So there are important limitations to these kinds of survey studies. Another study of 4,835 POTS patients, 41% had reported infectious triggers, while 31% reported physical injury triggers. These injuries or physical trauma included surgery, pregnancy, an accident, and a concussion. Among ME/CFS patients, several studies report similar statistics around physical injury. Environmental exposures are another commonly reported triggers of many of these illnesses, which I'll talk about a little bit later in the talk. And it's really important as we capture this kind of detail in our research and also in the medical history surveys and our studies. And especially as we keep in mind, do onset patterns and disease triggers inform treatment pathways, especially regarding the possibility of persistent infections or viral reactivation. In this slide, I'm going to talk about some shared risk factors for developing these illnesses. So female sex is a very important risk factor. In fact, all of these illnesses disproportionately impact female patients. They are 63 to 83% female across illnesses. Sex differences and pathological immune responses to infection may partially explain some of this. For example, males are at higher risk for more severe acute COVID and other infections, and females are at higher risk for long COVID and long-term illness after infection. Akiko Iwasaki's lab found that low testosterone in women is a predictor for women developing long COVID. There's also a new paper out showing that, or a recent paper out showing that female long COVID patients have decreased neutralizing antibody titers, so they may not be clearing infection as effectively. Another risk factor are genetic and hereditary factors. So hereditary alpha tryptosemia is a genetic predisposition that increases one's likelihood for developing MCAS or mast cell activation syndrome. Genes have been identified in all subtypes of EDS except for the most common form, HEDS, which is comorbid across this group of illnesses. There are also suspected possible genetic factors for ME/CFS, but more research is needed. So, for example, in a survey study of 150 ME/CFS patients, 13% had at least one first-degree relative who also had ME/CFS. Pre-existing conditions and a history of infection is a risk factor for many of these illnesses. So, for example, severity of acute illness and several pre-existing conditions, increased likelihood of long COVID, a history of frequent infectious illnesses, increased risk for ME/CFS, and chronic Lyme. Not treating acute Lyme with antibiotics can increase risk for persistent symptoms. So I just talked about comorbidities, and now I'm going to talk about less studied pathologies. So in January, as Talia mentioned, I co-organized and led an NIH webinar on less studied pathologies. This was the first research webinar of its kind on ME/CFS, and the first time that the NIH has discussed some of these pathologies within the illness. And you can watch this webinar on YouTube if you're interested. The webinar covered connective tissue and spinal disorders, mast cell activation disorders, gastrointestinal issues and neuroendocrine dysfunction, reproductive and gynecological conditions, some of which I'll be talking about today. It's important to note that all of these topics are less studied. They can greatly impact patient quality of life and severity, and they ought to be included more often within the scope of research on ME/CFS, as well as research on infection-associated chronic illnesses, which is something that we do in our lab at MIT. And regarding the term less studied pathologies, it's also important to note that these illnesses have all been historically understudied relative to their patient population size and to their disease burdens, though certain shared pathologies are more understudied than others. And while the webinar only covered research on these topics in ME/CFS, these pathologies are actually shared across subsets of patients with each of the illnesses in the group that I've been discussing here today. So I'm going to briefly talk about environmental sensitivities as a less studied pathology before moving on to discuss connective tissue disorders, spinal conditions, and reproductive health conditions. Sensitivities and allergies are common across these group of illnesses, including food sensitivities, and some patients also become especially sensitive to their environment. This is actually something we ask about in our clinical study and are hoping to better understand, especially whether these symptoms may be immune mediated. So focusing on ME/CFS here, between 16 to 44% of ME/CFS patients in the literature report that environmental toxin exposure caused their illness, most frequently mold and chemical exposures. And remember that multiple successive triggers is a common onset pattern in ME/CFS. So this begs several questions. Many buildings have water damage and mold. One question is whether or not mold exposure could contribute to some of the immune dysregulation that we see in these illnesses. That's something we hope to better understand in our lab. And could these illnesses, could the immune dysfunction in these illnesses also lead to someone becoming more sensitive to their environments? Environmental sensitivities are included in multiple diagnostic criteria for ME/CFS, which you can see in the second bullet point on the slide. Additionally, some studies show that as many as 87% of people with ME/CFS have the symptom of chemical sensitivities. So clearly this is a common symptom, but understudied. And these environmental sensitivities can be symptoms of mast cell activation disorders, which are comorbid with ME/CFS. However, much more research is needed to understand what may be contributed to these symptoms. I hope to be able to say more about some of this mechanistic research pending findings in our study. There are also significant rates of comorbidity between connective tissue disorders like hypermobile Ehlers-Danlos syndrome and hypermobility spectrum disorder, so HEDS and HSD, and ME/CFS, POTS, and fibromyalgia. I am working on a few research projects on connective tissue disorders and infection-associated chronic illnesses, but here I'm just going to really overview the literature. So in ME/CFS, 12 to 19% of patients may have HEDS, 50 to 81% of ME/CFS may be hypermobile. So in POTS, up to 31% of POTS patients may have HEDS, up to 90% of HEDS and EDS patients respectively may have POTS in a study of patients in EDS clinics. In fibromyalgia, a meta-study found that the association prevalence, so how frequently they co-occur, between HEDS/HSD and fibromyalgia ranges from 68 to 89%. So that's a lot. More research on connective tissue disorders and long COVID is needed, but in a large EHR study, around 23% of long COVID patients fit within a phenotype characterized in part by having a higher prevalence of connective tissue disorders. COVID-19 is associated with a substantial risk for autoimmune and autoinflammatory connective tissue disorders in a large retrospective cohort study. Case studies document long COVID patients newly developing joint hypermobility post-COVID-19. So it's really important to note that these rates of comorbidity are significantly higher than general population prevalence. It's estimated that only 0.02 to 0.2% of the population may have EDS, and 3.4% of the population may have symptomatic hypermobility, so joint hypermobility with widespread pain. There are many outstanding key questions here, such as, are people with hypermobility at higher risk for these illnesses? A recent study showed that this is in fact the case, that people with generalized joint hypermobility had an increased risk for developing long COVID. Does their hypermobility, do patients' hypermobility become more severe or more symptomatic after developing these illnesses? Do some people with these illnesses develop essentially an infection or inflammation-associated connective tissue disorder? This is something we are beginning to study in our lab, both through mouse models, and we also hope to do more research with human subjects and tissue profiling as well. We hope to identify mechanisms of connective tissue breakdown and infection-associated chronic illnesses. We're interested especially in immune and inflammatory possible mechanisms, persistent infections, and even possible mitochondrial and metabolic mechanisms contributing to this connective tissue breakdown. I also want to mention that spinal disorders, which are often related to connective tissue disorders, are seen in many of these illnesses, and that more research is urgently needed on this topic. So spinal conditions include upper cranial instability, such as craniocervical instability and atlantoaxial instability, tethered cord syndrome, and Chiari malformation. These spinal conditions can result in neuropathy, brainstem, vascular and nerve compression, cord stretch injury, and cerebral hyperperfusion. And symptoms overlap with ME/CFS, including neurological, orthostatic, cognitive symptoms, fatigue, and pain. On this slide, I'm going to review some of the literature on comorbidities, spinal conditions across these illnesses, which are significant. So an MRI study of 205 ME/CFS patients showed that 80% have disc bulging or hernias in the cervical spine, 83% have signs of intracranial hypertension, 64% have obstructions in C1 to T2, over half have spinal cord compressions at C5 to C6, and so forth. One limitation of this study is it did not have healthy controls. Over a quarter of ME/CFS patient in an EHR study of ME/CFS clinics had severe spine problems. So 26.5% of 913 CFS patients had severe spine problems documented in their health records. 21% of EDS patients have craniocervical instability, and 40% of EDS patients have tethered cord syndrome in an EHR electronic health record study of EDS clinics. And studies have found similar spinal conditions in a majority of fibromyalgia patients. So 71% of fibromyalgia patients in an MRI study had cervical cord compression, and 91% if fibromyalgia patients in another MRI study had short filum, which can be indicative of cord stretch injury or potentially tethered cord syndrome. So key questions include, what are the possible roles of infection, inflammation, and mast cell activation in the development or exacerbation of these spinal conditions? Mast cell mediators like histamine and tryptase can directly damage collagen. Klinga et al. Found inflammatory cell invasion, including mast cells and leukocytes, in the phylum of HEDS tethered cord surgical patients, and their phylum was half as elastic as the tethered cord. Their phylum was half as elastic as non-HEDS tethered cord surgical patients, therefore increasing the risk for cord stretch injury and the neurological symptoms that can stem from that. There is significant and emerging research on persistent infection in ME/CFS. Just one example is that HHV6 viral microRNA was found in the brain and spinal cords of ME/CFS patients, including cervical, lumbar, and sacral nerve roots. It's unknown how this may impact the development or exacerbation of spinal disorders, but an important area for future research. And as I mentioned, this is an area that we hope to study more as well. So next, I'm going to talk about reproductive health findings across illnesses. I worked with my colleagues at the Patient-Led Research Collaborative to write the first review of reproductive health impacts of long COVID. We contextualized these findings by drawing on research evidence of female reproductive health in illnesses that are often comorbid or may be associated with long COVID, such as ME/CFS, POTS, connective tissue disorders like EDS. Premenopausal women have a higher risk for long COVID and possibly for ME/CFS, suggesting that sex hormones and sex differences in immune responses to infection may play a role. To summarize our findings, these illnesses individually have increased rates of infertility, endometriosis, ovarian cysts, uterine fibroids and bleeding, lacking menses, irregular and inconsistent menstruation, intramenstrual bleeding, menstrual cramps, vulvodynia, painful intercourse, early menopause, pelvic congestion syndrome, gynecological surgeries, and adverse pregnancy complications such as preeclampsia, maternal mortality, and premature birth. Half to 2/3 of female ME/CFS patients report increased illness symptoms before menstruation, indicating that it may be important for us as a field to consider the menstrual cycle when conducting patient symptom surveys. Women with ME/CFS compared to controls disproportionately report irregular menstrual cycles, amenorrhea, dysmenorrhea, excessive menstrual bleeding, and bleeding between periods. Reproductive health conditions are common yet understudied in ME/CFS. Patients report increased rates of polycystic ovarian syndrome, ovarian cyst, pelvic pain, gynecological surgery, and endometriosis compared to controls. A longitudinal case control study revealed early onset menopause is a risk factor for ME/CFS, and menopause exacerbated symptoms in 38% of premenopausal and postmenopausal women with ME/CFS. A study found that women who had been pregnant in the previous year were 31 times more likely to develop ME/CFS. Pregnancy is reported as a trigger of both ME/CFS and POTS, accounting for between 3 and 10% of cases. And results are mixed on this, but pregnancy exacerbated symptoms in large subsets of ME/CFS and POTS. In other subsets, symptoms stay the same, and in other subsets, symptoms improve. So it will be important to understand the mechanisms of this and why this is occurring. Why do some patients report remission or improvement from pregnancies and others experience progression of their illness? If we understand the mechanisms of this, especially immune mechanisms, could the findings perhaps inform directions for research on treatment pathways? Few studies have investigated the impact of long COVID on female reproductive health. That said, we found emerging evidence suggests that similar to ME/CFS, long COVID can disrupt the menstrual cycle, gonadal function, ovarian sufficiency, menopause, and fertility. So for menstruation, menstrual cycle irregularities are common in long COVID patients as well, including changes to the length of cycle and duration and intensity of menses. Similar to ME/CFS, studies show that between 1/3 and 62% of premenopausal long COVID patients commonly experience an exacerbation of long COVID symptoms in the days before menses, as well as worsening of premenstrual symptoms. In a patient survey of nearly 1,800 menstruating long COVID patients, 34% reported menstrual issues, and within that, 26% had an irregular cycle, and about 20% had heavy periods. Case reports suggest that COVID-19 infection may be associated with long-term decline in ovarian health, including premature ovarian insufficiency, a loss of normal function of ovaries before the age of 40. Similar to ME/CFS, premature menopause has been found to possibly be more prevalent among long COVID patients in their 40s than the general population. Few studies have investigated long COVID in pregnant people. There was a small control-matched prospective cohort study in Brazil that followed pregnant women after testing positive for COVID-19, and 76% of these 84 women developed long COVID. This is possibly reminiscent of research that has found that pregnancy is a risk factor for ME/CFS. It will be important to research further whether pregnancy may be a risk factor for long COVID and how long COVID may affect pregnancy. And ME/CFS, POTS, long COVID, and EDS share many reproductive health conditions, symptoms, and menstrual irregularities. Similar to ME/CFS, in POTS, studies have found increased rates of dysfunctional uterine bleeding, secondary amenorrhea, uterine fibroids, endometriosis, ovarian cysts, and pelvic congestion syndrome. In POTS, menstrual cycle hormones have been found to affect hemodynamics, and menstruation is associated with an increase in dizziness. There's a study published recently showing elevated rate levels of different kinds of sexual dysfunction in female and male patients with POTS, including arousal, erectile dysfunction, and more. In EDS, if you'll look at the pregnancy column, it is associated with an increased risk for a host of pregnancy complications. Limitations of many of these studies include lack of healthy control or comparison groups, not screening participants for comorbid illnesses, and lack of consideration in the study design for factors that may impact menstrual cycles, such as vaccinations. So again, I stress the need for more research on reproductive health in infection-associated chronic illnesses. Here, I'll discuss endometriosis in particular. Research suggests that between 20 and 36% of female ME/CFS patients report endometriosis, and 20% of POTS patients report endometriosis. This is 2 to 3.5 times general population prevalence for endometriosis. Critically, the average time to diagnosis from symptom onset is 7 to 10 years for endometriosis. In regards to long COVID, a study of non-hospitalized COVID patients found that patients with endometriosis may have an increased risk of developing long COVID, but more research is needed to understand contributing factors. People with polycystic ovarian syndrome were found to have a 28% increased risk of COVID-19 infection after adjusting for other risk factors. Interestingly, research suggests that ME/CFS and endometriosis may share some overlapping pathologies and immune dysfunctions, which is on the slide, and we also discuss in our review. As this is a high-level overview, I'm not going to go too deeply into a discussion on possible mechanisms or endometriosis, but I do want to mention a very interesting area of emerging research is whether infection and possibly immune responses to it might contribute to the development of endometriosis. So last year, a study found fusobacterium in endometrial tissue of 64% of 79 women with endometriosis and in just 7% of healthy controls. In mouse models of endometriosis, mice inoculated with fusobacteria had increased and larger endometrial lesions, and antibiotic treatment reduced fusobacterium and the number and size of endometrial lesions in mice. In the Tall Research Group at MIT, we are studying mouse models of infection-associated reproductive tract pathologies. I am excited to share with you some striking preliminary findings. So the mouse on the left is an uninfected mouse. It has a normal uterus, ovaries, and reproductive tract. The mouse on the right was infected with a pathogen, and you can see that it develops severe reproductive tract pathologies, including enlarged, inflamed, and infected uterus, ovaries, and reproductive tract. So there are many outstanding questions about the roles and mechanisms and impacts of reproductive health conditions in long COVID and ME/CFS, as well as POTS and EDS. And we highlight some of these in our review. They include examining the roles of sex hormones and mast cell activation within the menstrual cycle, related fluctuations of illness symptoms. Additionally, how might hormone fluctuations in the menstrual cycle impact connective tissue laxity, and how might this contribute to illness symptoms? There's also, we raise questions about whether microclotting that's found in long COVID and ME/CFS, could that become exacerbated around the menstrual cycle? Important areas for future research include examining the menstrual and reproductive tract microbiomes with ME/CFS and exploring whether possible pathogen persistence in the reproductive tract, whether there's possible pathogen persistence in the reproductive tract. We are doing that in our clinical study, but I'd hope to see more studies include vaginal swabs and smart tampons to be able to really study this further. It will also be important to develop less invasive diagnostic approaches to endometriosis and these reproductive pathologies. I'm going to talk about kind of a few next steps for the field, and then I'm going to talk a little bit more about our research and how we are incorporating all of the topics that I've discussed today into our research at MIT. So in terms of next steps for the field, I hope some of the take-home messages of this talk is that these illnesses are incredibly heterogeneous, and they encompass many different organ systems, and basically the body is breaking down in many ways, both well-known and lesser known, and that it's incredibly important to screen patients for these common comorbidities and pathologies. I have a figure, but my talk was already getting too long, but I have a figure on diagnostic delays across these illnesses, and they rate the average diagnostic delay for these illnesses after symptom onset ranges from 3 to 30 years. So increasing screening for this and raising awareness of these comorbidities could be incredibly impactful for patients. Then what I would love to see more of, just as a scientist, as a researcher, is more case studies and pilot studies of promising off-label meds being prescribed at specialty clinics. And obviously, we need more specialist clinicians, and it's so wonderful that Bateman Horne Center is organizing this this series, because it's exactly what we need. I just looked up the Mast Cell Disease Society lists only 33 specialists in the country for an estimated possibly 56 million Americans with mast cell activation syndrome, and that's prevalence is based on kind of limited research, I would say. But the American Academy of Neurologists lists less than 30 autonomic neurologists in the country, and that's less than 1% of members. And on various kind of publications by the MECFS Clinician Coalition, it lists 21-ish specialists. So clearly, given the millions of patients, we need more specialists in these areas. And I would love to see more clinical research collaboration between the research labs in the field that are studying kind of some of the complexities here, and the clinics that are doing such incredible work and collecting important data. I think there's some really, really special areas for kind of research collaboration that could be highly impactful. Yeah, and then in terms of research, there is such a need for cross-illness research and a kind of a mechanistic understanding of these pathologies. So one is we need funding for clinical trials and clinical studies with multiple illness cohorts. So as I mentioned, doing phenotyping research to understand what are the shared phenotypes and kind of shared pathomechanisms and shared pathologies across illnesses could really help us understand treatments that could be helpful for patients with different diagnoses but overlapping illnesses, and also for patients who have multiple illnesses simultaneously. There's also really a need to develop standards and models and protocols for effective cross-illness research. I'll talk about our cross-illness research in a minute, but we launched last June the largest clinical study in MIT history, and it's designed to expand to multiple illness cohorts. And there are so many complexities when designing a clinical study to really span multiple illness cohorts, as well as cohorts that really focus on a feature of an illness. And it would be great to see kind of this methodology published and kind of discussed more broadly in the field. And then just in general in our research, there's a need to really screen participants for all of these comorbidities that I talked about and more, and these pathologies. And there's also really a need for research on highly complex patients and severe patients, and I'll discuss this, but we designed our clinical study to be able to be 100% able to travel to people's homes. And that was really important to us in the design of our clinical study, but that's not typical. And so designing research methodology to be able to study highly complex patients in their homes is going to be increasingly important. And then I would love to see working groups in the field of expert patients and clinicians and scientists developing research priorities and next steps for these less studied pathologies, because while there's a lot of discussion on important topics like neuroinflammation and autonomic dysfunction and pathogen persistence, and all of these are incredibly important topics, there's just less discussion around some of the topics I discussed, which can still very much impact patients' qualities of life. So bringing people together to identify collaborative research opportunities and priorities would be a great next step. So last year, in 2022, I had the honor of serving on the Patient-Led Research Collaborative Biomedical Research Fund panel. We funded $5 million in grants to innovative research on long COVID and MECFS. And one of the things that was really important to me and to us is that we required all grant recipients to screen for common comorbidities. So these include many of the things we talked about here, like hypermobility and HEDS and endometriosis, et cetera. So I'm just leaving here some of the validated surveys and questionnaires that we asked all grantees to incorporate into their studies. It's really like a first step towards what I hope will be kind of more robust screening in the field for all of the things that I talked about today and more. So I'm going to talk a little bit about our clinical study. So we designed and launched last June what is the largest clinical study in MAT history, and it's a comprehensive longitudinal, well, some of the cohorts are longitudinal, it's a comprehensive study, the neurological, neurocognitive, and immune mechanisms of these illnesses. So within the study, we do cognitive testing such as brain check. We look at we do EEG testing with WAVI. We do autonomic testing with a NASA lean test. We use a earpiece, a stat earpiece, to track cerebral hypoperfusion or cerebral perfusion throughout the study. We use right eye to track eye movement as an indicator of neurological function. We do skin barrier testing as an indicator of connective tissue issues. We do hypermobility screening. We're expanding that into spinal screening, screening for spinal issues. So heel toe testing, and hopefully incorporating the new biomarker for tethered cord that Dr. Klinga just published, and so forth. So really making this as comprehensive as possible. And we also collect multiple different types of biological samples. So blood, throat, saliva, urine, vaginal, also not listed here, but included sweat and fecal samples we collect. And we do really in-depth analysis looking for pathogen persistence and also doing immune profiling. We have incredibly comprehensive medical history and symptom surveys that are 40 and 24 pages long, and patients also just go through like a basic physical assessment when they come in. So currently our cohorts include long COVID, acute Lyme, and chronic Lyme and suspected chronic Lyme, because Lyme disease serology lacks sensitivity. So we really wanted to get the whole scope of chronic Lyme here, but we are working very, very hard, and it is one of my kind of key points of my job right now is being able to add an environmental sensitivities cohort, which includes patients across illnesses with that severe manifestation of environmental sensitivities that I mentioned, as well as a ME/CFS cohort. And we hope to be able to do a homebound cohort. So as I mentioned, this is entirely transportable, or it can be. And we designed it this way to be able to hopefully launch the most in-depth study of severe bedbound CFS patients that has been done, but hopefully we get funding for that. Yeah, this is our study. So we hope to identify new mechanisms of illness and identify phenotypes both within individual illnesses and across illnesses, and be able to hopefully predict who develops chronic illness after infection and why, especially in our longitudinal cohorts for acute and chronic Lyme. And we really hope to advance a deeper understanding of illness trajectories and mechanisms driving disease pathologies. And this was something that's really, really important to me, especially because, as I mentioned, I think sometimes the most complex patients can kind of fall through the cracks, and the most severe patients aren't able to come into studies and participate. And so designing this study with the complexities and severity of patients in mind was kind of first and foremost. And then I created a little list of how we incorporate many of the topics that we talked about today into our research. So for example, we screen in our clinical study for all common comorbidities and less studied pathologies that I talked about here today through medical history, through validated surveys, diagnostic criteria, in-person assessments. We use a Navisense for connective tissue. We screen for relevant symptoms and diagnoses for connective tissue. We use a Baton score and HEDS assessment. We also are including a number of different spinal assessments into our study, and we are developing a mouse model of infection-associated connective tissue breakdown for the spinal conditions. As I mentioned, this is something we are really interested in, and we hope to one day bring in a cohort before and after surgery to understand surgical outcomes in these patients, and then also expand to neurosurgical tissue profiling to really understand the mechanisms of connective tissue breakdown in these patients' tissue. But this is all kind of future research. and reproductive health. So our study includes a vaginal swab, and we hope to eventually collect menstrual effluent samples in some of our research. And we're doing multi-omics profiling on all of these samples, including the vaginal swabs. And I just want to mention that there are technologies such as smart tampons, like NextGen Jane, to study the menstrual microbiome. And I hope that more research in our field includes these kinds of considerations. And we also conduct mouse models. We also conduct research on mouse models of endometriosis and reproductive tract pathologies and infection-associated chronic illnesses. So that's just an overview of how one lab can take topics that don't necessarily have robust literature kind of informing them, and really do exploratory research to better understand these mechanisms that patients so clearly report and so commonly report, but we need more information about why. So these are some of my references. The rest are noted on my slides. And then I just really want to thank the TAL Research Group and the MIT Center for Clinical and Translational Research. All of my colleagues there. It is a big collaborative effort to do all of this research. And I feel so lucky and so grateful to work with the colleagues I get to work with every single day, thinking about how do we increase our understanding mechanistically of these illnesses, and especially the just kind of less considered aspects of the many different ways the body is falling apart, and how can this translate into both clinical care and hopefully the development of new treatments so that we can start to address some of the most complex patients and how we can improve treatment for them. Okay, I think that's it. Thanks so much.
Beth, I am looking forward to seeing what you can do with that research. That's amazing. And it's so understudied. And you're taking this on. Thank you. Dr. Brown.
Yeah, great overview. Very interesting research setup. Do you guys on your clinic, like your trial at sort of the end, do you have a control group that you're adding to that?
Yeah, we do.
Okay.
Sorry, it was on the slide. I don't know if I mentioned it. We have healthy controls, and that's actually a really important point, because if we think about the at-home cohort, especially, which is not happening, we don't have funding for that, but it's like the dream, is how do you characterize your healthy controls for an at-home bedbound cohort? So those are the kinds of questions we're asking now. But yes, for our in-person study, which is ongoing and will continue for the next several years, we have a healthy cohort, yes.
And the other thing is at the University of Utah, we're one of the NIH Recover sites. We have 2 cohorts, a main and then the pregnancy cohort. I'm not sure if you saw Tori Metz is the primary PI on that, where they just came out with the initial description of the PASC incidence is actually lower in this cohort than what we would have expected, kind of getting the, for some autoimmune conditions, for example, pregnancy is actually kind of protective, but there definitely were factors in the 9.3% that did have PASC, that there were variables, and I'd be curious as that goes forward to kind of tease some of those out. The people that do get it, why do they get it during that time frame? But that has been submitted for public. It was presented at, I forget which meeting Tori presented it at, but the publication should be coming out shortly. So
that's great. There's such a paucity of research on kind of these illnesses within pregnant people and pregnant women, and so many unanswered questions.
They're usually excluded from all of our trials. So it's like,
I know.
So I'm very curious to see what some of these are, because I mean, I was surprised. That was the first thing when she sent me the manuscript. I'm like, that's way lower than what I would expect for what we normally see. So, and I'm very curious to see some of the effects on fertility, menstruation, all of those things. I still feel like are very much the black box when it comes to really big data-driven research. And that, I think that's what's limited a lot of these fields, is that, it's a lot of, less rigid research methods and stuff that they've used in the past. And I think I'm curious to see how this will go forward with a lot of your stuff. So nice talk.
Yeah, I agree with you. A lot of the research I talked about today had small cohorts, unfortunately. And so We definitely need more robust research. Yeah.
Hi, Beth. This is Braden Yelman. I was thinking a little bit about all of the changes that occur symptomatically during menstruation and just kind of comparing that in my head to what's happening during pregnancy and the risk for ME/CFS a year after pregnancy. And it occurs to me, we think about this, or traditionally have thought about this from a hormone perspective. What are the influences of hormones on ME/CFS? But I was curious if you knew if there was work being done specifically on what's happening with the immune system during menstruation. I mean, pregnancy, for example, huge changes in the immune system as well as sex hormones.
Yes, there is work being done. So I have to think. So I'm collaborating on a menstrual cycle study that's being led by incredible researchers at the University of Melbourne and their neuroendocrine research program for ME/CFS, and Natalie and Chris. And I don't know how much I can talk about. So I don't know how much I can say. I don't know how much in public, but yes, there will be a study looking at immune symptom exacerbation and immune markers across the menstrual cycle. I'm aware of another menstrual cycle study in the UK. And then I also am aware of several grant applications to study the menstrual cycle across these illnesses. Really in-depth immune profiling have been proposed, as well as, I just don't know how much I can say. But so I know there are several labs that have applied for funding to study longitudinally the menstrual cycle across multiple menstrual cycles. I do know there are 2 studies that are kind of getting ready to launch. I'm collaborating on one of them. Yeah, that's why when I was going through this, I said, I hopefully will have more information soon. This is really the preliminary information that led to the development of these studies. So all the literature I kind of overviewed today is basically all the information that we have that can inform the design of the studies. And this next phase of research, these longitudinal with daily sample collection and daily symptom tracking, that data is going to be really exciting. So everyone kind of cross your fingers that we get funding for these studies. And then also I'm excited for the 2 studies that have already been funded to launch.
So I think it's fair to say, at least then, that not only are we just looking at the influence of sex hormones, but also what's happening to the immune system during this time of the month, during the changes, and how might that be related to what's happening for patients.
And we have hypotheses too regarding immune markers, hormone, like the homeostasis between certain aspects of the immune system, certain sex hormones, and also certain symptoms. Like we have hypotheses that we hope to study, but yeah, hopefully grants get funded.
And on that same topic, immune system is a bigger umbrella, but specifically I'm curious too, if we're looking at how the menstrual cycle changes mast cell behavior and mast cell activation. Is that being looked into?
Yes, that's part of it. I mean, it's always so hard to test for mast cell activation because of the reasons I think many of us are familiar with, in terms of also needing to, test in a flare or around a flare. And so for particularly mast cell, that's also where the daily symptom questionnaires can be really handy for these. These studies need repeated measures. And there's a lot of kind of thought that goes into the methodology of repeated measures around menstrual cycle studies. But those kinds of questions when it comes to MCAS are really important, I think. And yes, are being incorporated. There's only so much I can say, but hopefully this time next year, there will be a follow-up talk with findings and hopefully a lot of the proposed research, but exactly what you're saying and more. We have been designing and proposing what I think of as really comprehensive research and the menstrual cycle, taking into account really every single thing I talked about here, and then asking the logical next step questions and trying to measure that. So, yep.
So Beth, to the clinicians on this call, what would be kind of your takeaway and how it's, well, I guess I'm kind of saying the takeaway, which is it's so important to acknowledge just how all of these things can play together in the same sandbox, right? And that although these patients do have a multi-system presentation, understanding how all of this plays together and really kind of targeting those aspects can improve the quality of life for these individuals.
So traditionally, the way, when I talk to patients, especially patients who've been sick for a very long time, it can take them years and sometimes decades to individually get diagnosed with all of these things. And their care isn't coordinated across specialists, leaving them to do a lot of the coordination when there are so many unanswered questions. And so my hope is that we can work together as a community, both scientists as well as patients and clinicians, to inform research as well as clinical approaches that kind of comprehensively span everything I talked about today and more. Screen patients really fundamentally as part of research and also as just part of intake, and then go from there. I think everything I talked about today requires not only more research, but collaborative minds coming together to design effective research. As I mentioned, some of the models for how to do this, we don't have the kind of standardized methodology. And so I would love to see us coming together to think about the most important research directions, and then in terms how that can inform clinical next steps, because ideally we have more centers like the Bateman Horne Center, which sees people really comprehensively. And I often tell people, and this is kind of, I don't know, I often say the body's falling apart in many different ways, and some of the ways have more of a spotlight than others. And so my hope is that we can kind of shine a spotlight into all of these different topics I talked about, and then start looking at why are they co-occurring. And the thing that with one of the things that kind of, I guess, keeps me up at night, you could say, is that we have so many patients progressing towards severe illness. And there's so much more research that's needed on understanding the trajectories towards severity. So for example, anecdotally, we see, I mentioned the hypersensitivity patient. Many of those patients become homeless, unfortunately. Or then we see patients whose spines start developing pathologies and our connective tissue breakdown. They can no longer sit up. Or there are patients who can no longer digest and wind up on feeding tubes. And so kind of understanding the phenotypes of severe patients and how patients lose functionality and kind of fall off the cliff to severity, to me, is a very important area of research that's under-researched, but also will inform treatments, because if we can predict and then prevent and treat severe disease trajectories, that can really improve quality of life, just as we think about kind of treating individual symptoms or, ideally cures. But yeah, if we can stop people from getting worse and understand who is at highest risk for different trajectories towards kind of falling off the cliff of severity, I think that will have a lot of high impact. So when I help design research and when I help think about research directions, those patients are always on my mind. And so if we can incorporate research questions, both internally and for participants, that help us understand some of these disease trajectories, I hope more and more research goes in that direction.
So do we. Beth, thank you. You are out there doing amazing work, and everyone on this call for being here, for dedicating your time into learning more. This is the last of this particular spring series. We will be picking back up in the fall. So do stay on the lookout for more information on that. Sarah Day will be sending out the annual CME renewals survey. If you can just take a few minutes to fill that out, that helps us ensure that we can continue to provide CME for programs like this through the University of Utah. So that's really helpful. We also would like some feedback on what it is you're looking for the next program series so that we can adapt our content to really meet your needs and what you're wanting to hear. So be on the lookout for those things. It was so wonderful to see all of you again today. And until we meet up again, please take care.